Hello and welcome to another day of math. Today we're going to be talking about literal equations. So a literal equation is basically an equation that you can't really solve for a single number. It's basically you trying to isolate a variable, trying to get a variable all by itself. Because you can't solve it because there's usually more than one variable, which makes it impossible to actually solve because they're going to be different like terms that you're going to end that you won't be able to combine. So let's look at an example. Let's start here with number 2. So u equals negative 3a plus 4 and it wants me to solve for a. So I'm trying to get a all by itself. So I need to get everything away from it. So looking at what's next to it, I've got a best friend and acquaintance. It's a party problem, right? So I'm going to start by getting rid of this acquaintance. So I'd minus 4 to each side. But on this side, I have a u. U can't be combined with 4. So I have to leave it as u minus 4. Okay, because I can't combine those numbers. Equals negative 3a. So then to get rid of this negative 3, I would divide, right? Divide by a negative 3 to both sides. Now again, I can't simplify these because, again, I've got that u there. So that's going to give me u minus 4 is equal to over negative 3 is equal to a. So looking at that, I can see what a is equal to, right? It's equal to u minus 4 over negative 3. The a is by itself. That's as far or as simple as I can get it. That's all I can determine a is equal to. Without knowing what u is, then that's as far as I can go. And that's kind of the goal with literal equations, is just get the variable that it's asking for all by itself. Once you're done that, you're done. All you got to do. Shouldn't be too tough, right? Let's look at another example. So let's look here at this. So we have z equals m plus x, and it wants me to solve for x. So I need to get this x all by itself. So I've got that m next to it. If I want to get rid of that m, it's adding, so I just minus m to each side. Minus m. Z and m are not the same variables, so you can't combine them. So I have z minus m is equal to x. Hey, look, the x is by itself. That's my answer. All you got to do, right? Not too tough. Let's try another one. So this one I've got g is equal to x minus c, and it wants me to solve for x. Well, it's a minus c, so I got to get rid of that c, so I'd add c to each side. G plus c equals x. X is by itself, I'm done. Woo! See, these aren't actually that tough, right? Let's look at one more example. So let's look at number 13 here. So 13, actually let's look at 11. So 11, I've got g equals 2b minus 2 over a, and it wants me to solve for b. So b is right here. I need to get that by itself. Let's get rid of this 2 over a first, though. So just like if I'm trying to move like a 2b or whatever, I would add or subtract, right? If I wanted to move this negative 4y, I would add 4y. So if I want to move this negative 2 over a, it's the same idea. I would add 2 over a to each side. It's not really all that different, right? So that gives me g plus 2 over a is equal to 2b. And then I have this divide, or this 2 multiplying, so I divide by 2. And that gives me g plus 2 over a all over 2 is equal to b. And that's my answer there. Okay, so again, not too tough. And then let's look at number 13. So again, I'm trying to solve for x here. I've got a c and a y multiplying. So to get rid of them, I would divide, right? Now I don't have to divide them individually since they're both multiplying. I can just do cy and would cancel out both of those, leaving just the x. Okay, and then I'd have to do the same thing over here, which leaves me with g divided by cy is equal to x. Hey, look, the x is by itself. I am done. Okay, and that's literal equations. Should be a pretty quick, easy day.